Let's now look at the data analytics methodology or a machine learning methodology. See, we usually start off with a business requirement or a business problem. A business problem is a place where somebody says, I have an issue. Can we look at doing a root cause analysis? A business requirement is more like, I want to improve my revenue or reduce my cost. Either case, we start off with a statement like that. And that leads to what is known as a target variable. Okay, so it could be sales, it could be cost, it could be profit. Now we go and hypothesize what are the various input parameters that are required, which actually impacts my target variable. So I'm looking at, let's say, sales or margins. Let's take sales. What impact my sales? Depends on my customer rate card, number of employees in my project. It could be the kind of services that I'm doing, whether it is high-end services or low-end services. There could be various such factors. All of them are part of this hypothesis questions. So we become extremely creative, and we try to identify as many parameters as possible without worrying about whether you will get the data or not. The next stage, you identify the data. So for each hypothesis question, essentially where you're asking, is my sales dependent on the rate card? We identify the rate card for each of our project or all our projects. We identify where are we going to get that information, not just rate card, any field. We try to sample the data. So there are many data types, there are many sourcing area, and there are many sampling techniques. We sample the data and then we bring it into our system. Once we have brought the data into our system, we perform data cleanup and transformation. This is a very critical step. Many of the models don't run when you have missing data, and you can't blindly replace missing data with zero or mean or median unless and until you understand the ramifications of doing so. So we got the data that is cleaned up, and once we do that, we are now ready to do our analysis. The analysis itself is split into two parts. The traditional analysis that we have been doing, where we apply tabulation or we apply statistical functions or we apply visualization. We have been extensively using visualization using Excel to create bar charts, pie charts, line charts, combo charts, so on and so forth, along with the help of tabulation. We have been able to identify and perform root cause analysis and solutioning to come out with actionable items that help solve the business problem in the first place. So these are actionable insights that we are looking at generating. So in the exploratory analysis, we use statistical techniques like mean, median, mode, variance, standard deviation. We also look at covariance, correlation. We perform outlier analysis to look at extreme values. So we use different types of charts, pivot tables, pivot charts. We slice and dice the data within region, within city. How is my performance? How is my rate card? Is there an issue with my employees? Is there an issue with morality? Is there an issue with a specific customer itself? So we try to do an analysis to get top level indicators. Now we may not nail down how exactly each of these parameter impacts your analysis, but at least we are in a position to understand and identify key variables that impacts your target variable. It's always trying to align your thinking against the target variable. Once you have exhausted that and you have a good indication, we move on to the analytical modeling step. Analytical modeling step itself has got many types of algorithms. So if the target variable is numeric in nature, we use regression. If the target variable is categorical in nature, we use classification. And sometimes when you don't have any target variable at all, now you look at using some other techniques like clustering or market basket analysis. So we use different analytical modeling steps in different scenarios. Now once we do that, we come out with inferences, we come out with recommendations, actions, and then we try to implement and we look at evaluation of these actions. Now when you do your modeling step, obviously you don't just rely on one model. Okay, so even within regression, I might create a train test split, train and test, and I might test it out with linear regression. I might use decision tree. I might use random forest. I may use lasso regression. I may use ridge regression. There are many techniques for regression type of algorithms. Each of these techniques, so I could look at either an R-square score to understand how well the model is, or I can even look at something called as a root mean squared error, RMSE. So root mean square error is nothing but my original value of the target variable minus the predicted value of the target variable using our model. You kind of square them, you add them, you calculate the average. It's very similar to your variance calculation. Variance is nothing but every value minus the mean and then you square it, you add it. RMSE is very similar, but instead of in variance, the difference between variance and RMSE is that in variance we compare it against the mean value, which is your baseline model. In RMSE, we compare it against our regression model or regression line. So obviously our regression line is much closer to the answer, so your RMSE should be much lower than the variance. Now not only that, we are looking at RMSE value across all of these algorithms, and then whichever is giving you the best output, we try to use that algorithm. Within each of these algorithms, again we try to do a train test split to ensure that there is consistent performances.